This lecture is based on the chemical kinetics order of reaction. This is a minor topic but is very important for chemical kinetics. So basically, order of the reaction basics at the very initial preference to the concentration of the species. Just suppose that we do have an species NH3 ammonia. If we will see at the concentration, so it will be something like R is equal to K, the rate constant, the concentration of A plus the concentration of the B. Now, according to this standard formula, we will break this ammonia according to the stoichiometric coefficients. Just suppose that the breakage of the ammonia is like N plus NH, or we can also take it as N plus H2. Now, first thing that should be noted is that the order of the reaction does not depend on the theory. It totally depends upon the actual practically approval. If you are given that NH N plus H2 is equal to ammonia, you have to accept it if it is practically proven. It depends upon the question that how the question is given. If the question states that this is proved, that means this is the standard form. I'm going to tell you how, but at the initial, just understand this, that these are two stoichiometric coefficients. As you can see here, N and H2. Now, the coefficients is basically the stoichiometric number that is given here. There is nothing given here, so we'll consider it as 1. That means 1 mole of the nitrogen and 1 mole of the hydrogen is being used. That means the concentration coefficients of the NH2 will be N. This mole, number of moles, will be written here as a power. So 1, and we know that the number of mole of the H2 are also 1. So this will be probably the standard form of that. Let me remove it first, and then I'll write it properly. Okay, so we do have sufficient space now. Okay, let's transfer it here. R is equal to K. Now here the K also depends upon what? Depends upon the practical experiment. It cannot be predicted theoretically because we are studying here the chemical kinetics that is basically based on the practical. Apart from that, if we're gonna place an concentration of N and its power will be 1, and concentration of H2 hydrogen and its power will be also 1. If we have to find the order of the reaction, we're gonna add the powers. So here the standard form of that will be that you have to add x and y that are the power of that. So we do have to add 1 with 1, 1 plus 1, and that is basically equal to 2. Now what does that means actually? That means when the reaction is doubled, or when the reaction happens, the concentration of N2 and H2 will be doubled. What does that mean? That basically means it is the second order. Now you will be thinking that what I am talking about the order. So basically, you can see here there are basically 2 to 3 types of order. The order starts from the whole number 0, then 1, 2, and then so on. So basically the concept behind the order is that how the rate of the reaction is proportional to the rate constant. That means the concentration. That probably shows us how the rate of reaction is playing a role in the concentration of the molecules. At the initial, if you have a look on the first example, so here the power of the X is 0. Why? Because there are no moles that are being used. Just suppose that H provides H. Now this is what this is, nothing. Like H is when freezed, or just remain this. Just suppose that we do have H2O, the water, in the liquid form, but after a specific process the water becomes solid. How? Because of the freezing. Now in this state there isn't any change in the rate of the reaction as well as the constant. How? 1 mole, isn't there is any change. If this will be double, this will be double. If this will be single, this will be single, or etc. It will also remain constant. So this is basically the concept behind the order. Now as I told you, there are specific types of the order. If we talk about the first order, so basically first order states that whenever the concentration, I mean to say that when the concentration's power is 0, or if it is not 0, if it is 3, but when we will increase the rate of the reaction and it does not affect on the concentration, that basically means it has 0 order of reaction. If we increase, just suppose that this is the letter 1 and it produces letter 1. If we will make it 2, it will be 2. That means if we double it, it will be double. That means it's the first order. If we will double the rate of reaction and it becomes 4 times, that means it is what? It is the second order. If we'll increase it double and it becomes 6 times, that means it is the third order of reaction. This is the basic concept behind the order of the reaction. Let's have a look on another example. Have a look at this, the differential rate law for different orders. If we have the 0 rate of order, so basically it will be equal to d upon t. The concentration will be at the not the negative, but still the product that we will provide will move like this. The starting point will be like this. The graphical representation, it will decrease. Why? Because as the product increases, the reactant decreases. So that's why it is being negative. There is another collaboration of the negative sign, but still we do write it. So the concentration of this is directly proportional, but it stays constant. Like it doesn't matter that if the power here is 1, 2, 3, 4, it will stay k to k. If we'll talk about the first order, so if we'll make k 1, so the here k will be multiplied by concentration of the 1. If it is here 1, so it will be 1. If here is 2, it will be 2. Apart from that, if we'll talk about the second order, so basically second order is square the concentration. That means if here it is 4, so for the second order we'll square the 4 and that's 16. That means the answer will be 16. This is how it works. Basically, here is a proper chart for the rate constant or order. So let's have a look on this. According to this, the standard form for the order is rate is equal to Kax. that means if we do have the first order, the power would be 0, right? And we know that anything that has power 0 is equal to 0. So here the rate of that will be equal to R is equal to K simply. If we talk about the units, so the unit will be this: mole, liter inverse, liter, or it is also termed with dm cube. So whether it can be liter, whether it can be dm cube, so it will be mole per dm cube per second inversed. If we talk about the second chart for the first order, so here if we'll make it first, that means the concentration will be taken for a single time. If we'll take it single time, so as you can see here, we know that there is mole inverse, dm inverse. So the mole inverse, dm inverse will be cancelled. And what we'll left, we'll only left the second minus 1. What does that mean? We are only taking the concentration unit here. That's why the concentration will be cancelled with the rate's constant concentration. And what we'll left? We'll left the second, as we know that the formula of the rate is d and nani concentration divided by dt. So here we are only left with the dt. After that, if we talk about the second order, so it will be square and the unit will be this. If we talk about the third order, unit will be this. So this is how the order works. I hope that you get what I'm trying to say. And if yes, please like this video. And thanks for watching.